Welcome back, students. In this video, we're going to go over Module 5, Topic 5, proving right triangles congruent. The standards for this topic are GR 1.2, prove triangle congruence or similarity using side, 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 angle, side, angle, side, angle, 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 side, and later angle, angle, and hypotenuse leg. GR 1.3, prove relationships and theorems about triangles, solve mathematical and real-world problems involving postulates, relationships and theorems of triangles. Excuse me. GR 1.6, solve mathematical and real-world problems involving congruence or similarity in two-dimensional figures. The objective for this topic, you guys are going to use the right triangle congruence theorems to solve problems. We're on page 17 in Module 5 packet. This is start with the warm-up. I'm going to ask you to pause here, work the warm-up, unpause and see how you did after you're done. I'm going to wait 3 seconds, excuse me, and then I will continue. All right, page 17, warm-up. Match each pair of triangles with the congruency postulate, which would prove that they are congruent. Excuse me. It just, well, I was thinking we had a word bank. Never mind. All right, so number one. Let's see here. So you notice we've got a 7 here, 7 there, 8, and 8. So, you know, the book doesn't always give us the congruency the same way. You know, we're used to seeing the arcs for the angles and the dashes for the excuse me, the sides. But sometimes it's a little simpler than that. Like here, we're talking, we don't have the arcs, but we see that angle A and angle E are both 60 degrees, so they are congruent. We notice that AB is 7 units long, EF is 7 units long. So those are congruent. And the AC is 8 units long, and DE is 8 units long. So you have a side, an angle, and a side. All right, let's see, number 2. Let's say we got a box. We have angle E and angle A are congruent. And ED and AB are congruent. Excuse me, sorry. So we have a side, an angle, and a side. Notice the side is between the two angles, so we're going to write it just like that. S, A, S. Side, angle, side. I'm looking at it. It's, good Lord, excuse me. It's angle, side, angle. Notice the side, or the S, is between the two A's. The side is between the two angles. Sorry, it's been a long day, guys. All right, number 3. All right, number 3. So we have a side and a side. We're supposed to have 3, so it's not giving us a third. However, what do we notice about these angles in the middle? And we'll get you guys in class, and we'll keep pointing. Can't do that in the video, but these two angles here, ACB and DCE, are vertical angles. It's created by these two lines intersecting. So this angle here and this angle here. Right in here above it. I'm just going to abbreviate, but those are vertical angles. So now we have a side, an angle, and a side. One second. Okay, scooting over. Excuse me. There we go. So number 4, they give us this angle is a 90-degree angle. Notice that ABD and CBD are vertical. Or I'm sorry, they're not vertical. They're a linear pair. So linear pair equals 180. Well, if this guy's 90, 180 minus 90 is 90. So they both have to be right angles. So let me just draw that in. Thing to take notice and bare bones here with this. So line segment DB, it belongs to both triangles. So it's congruent to itself by a reflective property. So now we have a side, an angle, and a side. Okay. All right, let's scoot up here. Still on page 17. Again, the longer 5 packet. All right, so proving triangles congruent. Because right angles are congruent, we can use SAS, AAS, ASA criteria for triangle congruence to prove theorems related to congruence in right triangles. The theorem 5.6 is the leg-leg congruence. Now, up until this point, we've been calling the sides of the triangle sides. Well, we're going to start referring to them as legs when we're dealing with right triangles, and they're also legs when they're isosceles triangles. You'll see in the next video. Let's see here. All right, so if the legs of one right triangle are congruent to the corresponding legs of another right triangle, so leg, 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 then the triangles are congruent. So given right triangle ABC and right triangle DEF, AB is congruent to DE, AB congruent to DE, and CB is congruent to FE, so that triangle ABC is congruent to triangle DEF by LL, or leg, 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 leg. Excuse me. Scoot down just a little here. All right. Whoops. A little sideways. Okay. Theorem 5.7. Hypotenuse angle. Excuse me. Give it just a moment. Okay. So 5.7. Hypotenuse angle congruence. If the hypotenuse and acute angle of one right triangle are congruent to the hypotenuse and corresponding acute angle to another right triangle, then those triangles are congruent. So see here, we're talking about the hypotenuse, so that's the long side. It's always the longest side, and it's always directly across from that right triangle. So hypotenuse angle. I'm not talking about the angle that's right, it's a right triangle because it has a right angle. So we're talking about either of the other acute angles. So these two corresponding acute angles are congruent, so it's hypotenuse angle. And right here it says given right ABC and DEF, so ABC, DEF, AC and DF are congruent, and those are the hypotenuse, and angle C and angle F are congruent, so that ABC and DEF are congruent by HA, or hypotenuse angle. Excuse me. Just a moment. Flip over. Page 18. Top of the page, got a couple of theorems. These are, so theorem 5.8 is leg angle. So if one leg and an acute angle of a right triangle are congruent to the corresponding leg and acute angle of a second right triangle, then those triangles are congruent. So just like before, but we're talking about a leg, not the hypotenuse, and one of those other angles. And then theorem 5.9, hypotenuse leg. So if the hypotenuse and the leg of one right triangle are congruent to the hypotenuse and corresponding leg of another right triangle, then those triangles are congruent. Let's zoom out a little. We've got a couple of proofs. I do is on the left. So number one. So Craig and his brother are painting a house. The brothers use ladders that are the same length. If they place the ladders at an equal distance from the house, will each ladder reach the same height on the roof? Construct a narrative proof. Hint, draw a diagram. So we're going to draw a diagram, and then we're going to work down here. We have a word bank at the bottom. Excuse me. So I know before I get down here that, so we got the house. So we're going to have Craig right here, and his can't write tonight, bro over here. So this is the house. This is the ground. I'm just going to say how H for house, G for ground. H for house, G for ground. This is L for ladder. It's also going to be the hypotenuse. So, whoops. But I know that the ground and the house are going to be parallel. I'm sorry, perpendicular, and they're going to make a right angle. So, like I said, I'm just going to draw that out before I even look down here at the word bank. So let me just scoot this a little bit here. So it says because the wall of the house is perpendicular to the ground. So there you go. The triangles formed by the house, the ground, and the ladders are, so what is that? It's a right triangle. Let's see, where are we at? Yeah, there you go. Okay. The blank are congruent because the ladders are the same length. So there's the ladders. Let's see, look down here. We got legs, now hypotenuse. Because that's what I told you the ladders were. They're the hypotenuse. That's the long part, because the ladder is longer than the house because you're going to lean it down. Okay. The corresponding blank along the ground are congruent because the ladders are placed the same distance from the house. So the ladders are placed the same distance. And let me start marking this. So the ladders are congruent because they said the ladders are the same size ladders. We know this leg, and that's what we got to write in there, leg. Let's see, the corresponding legs, plural, are congruent because the distance between the house and where you set the ladder down is the same distance. So the triangles are congruent by hypotenuse leg. And of course, that's right here. Theorem, or HL, and it tells us right there. Thus, AB and DE. Now, I don't know where they get that, but I can tell you they're saying AB and DE, it's the house. The house is congruent, or the height is the same with the ladder, the original question. Those are the same. Those are congruent. And it's because by CPCTC. And let me show you. So we have CPCTC and we have congruent here. CPCTC is the corresponding parts of congruent triangles are congruent. So we've already proved the triangles were congruent because of hypotenuse leg. And because we already know they're congruent, then we can go ahead and we know that these are congruent because the triangles were congruent. So you can conclude that the ladders reach the same height on the house. Okay. All right. Number 2 is a you do. Please pause the video here. Work this proof on your own. I'm going to wait about 3 seconds before I continue. Once you're done, watch and let's see how you did. All right, number 2. The fence has parallel supports, so they're parallel. That's the arrow. You can't see it because this was a color page until it got printed. So these are parallel, and the crossbar forms 2 triangles. Well, this is also the hypotenuse. So it's going to be the hypotenuse for both of these because it touches both triangles. So we're going to go ahead and mark it before we even go any further. Complete the proof to show the triangles are congruent. So I keep telling you guys in class, these proofs are like puzzles. So start putting them together as you start reading the problem. So we've already got the hypotenuse mark. So we know when we get down here to where we're talking about the triangle congruence, it's going to have hypotenuse. It's H something, which we only have one option. So we know we're going to talk about some angles in here. So they said those were parallel, and well, I guess it's going to tell us about that those are right. But let's actually, yeah, see, here you go. Given B and D are right angles. Given. Okay. Triangle ABC and CDA are right triangles. All right, well, it didn't tell us that. So let's look down here at what our choices are. CPCTC, well, we haven't proved they're congruent yet, so can't use that. Reflexive, that's only when we're talking about something being congruent to itself. Actually, you guys can't even see this. I'm down here beyond the page, excuse me. CPCTC, reflexive. We know it's not HA because that's when we're proving the triangles. We used one given. This was not a given, so alternate interior angles, no. We're talking about right triangles. Definition of right angles. Well, what makes a right triangle? Right angle. So that's where that is. Right angles. Okay, mark that one off. All right, number 3. AD is parallel to BC. That was another, no. That was another given. Okay. Number 4 says DAC. DAC is congruent to BCA. So let me mark those first. All right. So let's try that again. DAC, so this side of the crossbar, and BCA, so this side of the crossbar. So hope you guys, we can look down here. We know it's not this. It's not reflexive because we're not talking about the same thing. HA is for the triangles. The only thing left is alternate interior. Well, we had 2 parallel lines, and we have the top left and bottom right. So that would definitely be alternate interior angles. All right. Number 5, AC is congruent to AC. Oh, we already marked that. That's the hypotenuse, and that it's AC and AC, so it's reflexive. All right. Number 6. Now we're talking about the triangles, ABC, CDA. ABC, CDA. We have a hypotenuse and we have an angle, and we only have one option. So there you go. And you can just put HA because I know you guys are tired of writing. So there we go. Let's flip over to page 19. And this is going to be the end of this topic. Give me just a moment to mark in our red boxes. I like to keep them red. Red box, red box. All right, let's start. Okay. All right. Now wait. So number 3, page 19. Determine whether each pair of triangles is congruent. If yes, include the theorem that applies. All right, so part A. So let's see what we got. So remember, right triangles were they both have a right angle. That's how they're right triangles, so we're not going to continue to talk about them. So what do we have here? We have a leg. This is the hypotenuse because it's directly across from that right angle. Notice, so XZ, this line in the middle, I'm highlighting it. It belongs to both triangles. So it can be congruent to itself through the reflexive property. So now, since they share a hypotenuse, it's hypotenuse leg. All right, B. So there's your right triangles. We have an angle, we have a leg. Or a leg and an angle, because it's LA. C, we have a leg and a leg, so we have an LL. And not cool J. D, we have a leg and an angle, a leg and an angle. Let me just mark a couple of these. Just so we got a leg and a leg. Just so you guys are getting the idea, especially the ones of you that are just fast forwarding to get the notes. All right. Let's see. So that was D. Okay, so E goes here. So we got a hypotenuse and we have an angle. Hypotenuse angle, or ha. And F. We have a leg, but we don't have anything else. These don't share. There's nothing else marked, so these are not congruent. All right, let's zoom out, not back in. I'm gonna try to fit as much as I can. Well, okay, can't fit anymore. So we'll start reading and then work our way down. I'm gonna have to draw the diagram anyway. Excuse me. So the number 4 here on page 19. This will finish up this topic. In the diagram, the support beam BX is perpendicular to the deck of a bridge. All right, so we're going to say this is the deck. This is BX. It's vertical support beam. And it's perpendicular, so it makes a right angle on that side and that side. The two diagonals, AB and CB, so AB and CB are equal in length. Well, equal in length, equal in congruent. BX belongs to both of them. See, it's in the middle. It's congruent to itself. So even before we even finish reading the problem, I'm already working here. I hope you guys will catch on to this, please. Okay, write a 2-column proof to prove that the two triangles formed by the vertical support beam are congruent. Draw a diagram. Well, we already got that. Ahead of you, bro. Our given is that BX is perpendicular to AC. Perpendicular makes a 90-degree angle. And that AB is equal to CB. It's also congruent. That means the same thing. Hope we're catching on. Number 1, BX is perpendicular to AC. That's given. Cool. I'm going to scoot a little because I want us to see the word bank at the bottom of the page. Okay. Blank, the definition of perpendicular lines. Well, how do we know this is perpendicular? Because it makes those two right angles, AXB, CXB. Let's see what we got here. AXB is congruent to CXB. Well, that's fine. But that's the triangle. The triangles are right triangles. Well, yeah, but we haven't gotten there yet. The angles are right angles because that is perpendicular. So this is the one we want. Angle AXB and angle CXB are right angles. Sorry, we're way over here. Hope you guys can see that. So we marked that one off. Look at number 3, definition of right triangles. These were right angles. These are right triangles. Why? Because they have those right angles. So, triangle AXB and triangle CXB are right triangles. So that one off. Whoops, missed it. Okay. Number 4, reflexive. What down here can be reflexive? AB and CB? No. XB and XB? XB and XB? Yes. XB. Congruent to XB. Okay. Number 5 is given. Let's pull this down just a little. So we already used this given. That was the first thing. So this is the only thing left. AB and CB. So I'm going to scoot up. So AB is equal to CB. Line segment. Number 6 is the definition of congruent segments. Well, what would we change here? What have you guys heard me say 1,000,000 times in class? Here it's equal. Here it's congruent. That's the definition of congruence, is equal. That's why it's that way. So anytime it says that. All right, last it's blank. Well, the only thing left is the triangles and HL because we had a hypotenuse. We had a hypotenuse and a leg. So it has to be the triangle on the left and the reason on the right. So triangle AXB is congruent to triangle CXB. And why? Pray tell? Hypotenuse leg. All right, guys. That's it for tonight. If you have any questions, let me know in class. Send me a message on Team or Focus. Have a great weekend. See you on Tuesday.